Okay, so let's move on the second one, which is palindrome number. Basically it has that if our previously we checked for 234 in reverse number. So here, if some if a number is 234 and if I found its reverse from the above code 432, so if they are not same, they are not palindrome, so that is false. If something is 111, its reverse will be 111 only, and hence they are true. Yes, this is possible. So I don't think I have to do much in this. Like I could write here also that I got the number. I did a see out. Okay. So I could just do one thing, that if this, or we could just store it. We don't need to int new num is equal to this. I could also write palindrome. I don't know why I haven't written this, but okay. So I have this new number and I say that if this new num, oh god, come here, if this new num is same as my num1, so I will return or I will do a C out of 2 as C out false. Achha. Why I do these? I don't understand myself only. ठीक है. So let's try running this. When I run this and I give let's say 1 2 3, so of course the reverse will be 3 to 1 and that would not be equal. So wow, now what happened? I did okay, I have not saved it, my bad. Autosave is I guess not enabled here. So this is 1 2 3. Okay, 0 0 means false. If I would have given 1 1 1, wait, first run this 1 1 1, then here it gave me 1 because of course here we have used this integer, so it can't give like this, so it gave me a 1. So I think yep, that was the palindrome part we did. Then Armstrong, I know what is Armstrong. Suppose our above number, this was 1 2 2 3 4. So if 2 raised to power, like the power of 2 to the power, like 2 3 4 has a length of 3, so 2 ki power 3 plus the next number is and this is 3, so 3 ki power 3, 3 ki power 3, then again power, and then 4 ki power 3. If this will be equal to 1 2 3, then our number is a Armstrong number. Such numbers exist. I think it was like I guess it was 153, because 1 cube is 1 only and 5 cube is 125 and 3 cube is 27. If I add this up, this is 7 5 is 12 plus 1 13, that is 3, and power carry 1, so this is 2 2 4 and 5 yep, 1 5 and then the rest one. So this is equal to the number. So I think this is easy. Do I need to write that? Should I write this? That is the real question. Okay, let's write this. Maybe I could have forgotten how to use par or something. So this is my Armstrong.cpp. We will write everything from scratch because we have to. Hash include IO stream using namespace std, then int main return 0. Okay. Now we are talking about some numbers. So int n, we will take that n, and after that we will solve it, that either something could be true or false. So cout I'll do solve of this number. Okay, and here bool solve, and we provided the number which is num. Now we'll say that what I wanted, that if I get the number, I should do its par to the length. Okay. How people get the length of number? Is it like num dot length? Maybe. Let's give it a try. What happens next? What could happen next to max? Must have a class type, but it has a type integer. That means we can't do this. Okay. I have one way, but I think that is a bit long. But let's give it a try. And count is 0 while our num is greater than 0. We will do that I should just divide it, because right now I just need the count. So I'll keep on dividing it, and I'll go on increasing the count. In this way I'll be able to increase the count, right? I hope so. I'm going right. 1 2 3. First time I did, I will get 12, and count is 1. If second time I do, it would only be 1, right? If I divide it by 10, I will get 1 only, and the count is 2. The next time it is greater than 0, and if I divide this by 10, if I divide 1 by 10, I'll get 1 remainder, so the count become 3. So okay, I got the count. Now till this is greater than 0, I will say that int will use res outside. Res plus is equal to par of remainder and count. Now what is remainder? Int rem is equal to this num modulo 10, and this num is num divided by 10. Here I'll use int res is equal to 0. Okay, this is one thing. Now if res is double equals to the number itself, then we'll return true, and this will break the loop. Otherwise you're always going to return false. Let's clear this and try to run this. A ARMG. Here also I think I need to do ARMG. No such file or directory. Oh, sorry. MG only. Okay. Now if I say 1 2 3, so it will be 0. But when I say 1 5 3, which we already tried, oh no, why 1 5 3 is giving 0 by this will always do the remainder. Suppose 3 comes, so 3 to the power 3 3 to the power 3 is 27. We'll add 27 to this, then 5 will do, then 1 will do. What is the issue then? What is the issue? Okay, I think the issue is in running RARMG.cpp minus ORI. Okay. Let's first put some things to trash. For reverse, our reverse file was meant. For ARMG, we don't need anything. ARMG.cpp minus OARMG and then this. And what is this saying? Undefined symbols for this not found. By which symbol you are not finding by? I don't think I have used any symbol that is not usable or something. Now it rained. Wow. 1 2 3 is expecting to give what 1 2 3 will give, by the way. Check. 3 to the power 3 is 27. The power 2 is 4. 1 to the 1 is 8. This can never give 123. Acha, again there comes. Oh no, that was not it. What we tried which was not this? 2 3 4 can never be. If I read 2 3 4, I get 1 only. That means every time I'm getting true. How come this? Int res is 0 and res is double equal to num. That is interesting. Now comes to GPT, but we don't have much time. I need to cover a lot of things. What is issue in this for Armstrong? Num becomes 0 after first loop. Acha. Second loop never runs. So num is already 0. This loop is skipped. So comparing num is already 0. You should compare it with original number. And we need to see math for par. Use one original to restore it. Thank God I did it. So first we need to include this C math thing. ठीक है भैया. Hash include C math. Is it cmath.h? No, everything is not .h. Okay. Int original number is equal to num. Got it? Now after this loop my num becomes 0, right? Yep. So we will say that num is equal to original. Got it? Okay. Here also it is 0. So like, why do I even need to do this? If that is 0, original is still there. Let's give it a try. 1 2 3 I'm expecting 0. Yep. Then 1 5 3 I was expecting 1. How come 0 again? My number is 0 and this will never run, so I really need to restore it here, and then should try to run. 1 5 3 is 1. 1 2 3 should be 0. Okay. 2 3 4 is 2 0. Okay, now it's working fine. So this was a good one, that we need to restore it the way we have used. Good. Do we have any better version? Do we have any better version than this? Because that must be. I don't think people use this restoring thing or something. Avoid power because it works with floating numbers. Compute powers manually using integers. Okay. And Armstrong is original is number, digit is 0, temp is num, count. Here also they count. Then they calculated the sum. No, I don't think there is any difference. If it is, I'm now comfortable with this. Moving on the next part. So this is the done. Then comes the prime number check. In prime number, what so far I remember is we check from 1 to root n. 1 to root of n. If in this if number is 13, so root of 13 would be what? 4 into 4 is 16. 3 into 3 is 9. 9 and 16. In mid of this will lie 13. So my Dumbo mind is quite confused now. Should I go till 3 or should I go till 4? And that also, suppose even if I go till 3 or 4, you can say, then what will I do? I run a loop from 1 to 4. Okay, I'm okay with that. Now what? Now I need to check a prime number is what? If something is divisible by 1 and itself. So if from 1 to root n, if any one of this will divide the number, like from 2 to that, from not 1 to that, from 2 to that root n, if anyone will divide, they will not remain prime. I think that can work, but now I'm still on the same thing, that what would be my root of n? Instead of root of n, I think I should take in 9 and 13 case, I should take a lower part till 9. Yeah. So I think that is the like easy part. Now I just run a loop and check that if something I'll run a loop from 1 to root of n. Root of n, I could simply say that I into I is less than n, or sometimes we use equal to also. So if that is equal to or less than, we could just check that if this I divisible by, like if I find remainder divided by n, or like that number get divided by any of this from 2 to this, then we'll need to return false, otherwise we'll return true. I think that is the easy part. I will not write it, and this can't even come. Sieve of Eratosthenes. This in this what happens is there is a range of numbers, like someone will say from 1 to 50 count the number of prime numbers. I guess that sort of something, that from a particular number to number we just need to count the total number of prime numbers. But there is one thing, here we start from 2, but now the thing is we'll use 2 loops. In first loop I'll do okay, like if I'm searching from 1 to 50, so first I will say that 1 to 50 everyone is let's say true, that everyone is prime. And we all know that prime of 0 and prime of 1, like 0 and 1, they are not prime, so I'll just mark it false. Now from 2 onwards to that given range, suppose even if it is 50, so I'll say that now everyone is prime, and 2 is of course our smallest prime, so that to count. Now if my 2 is prime number, so what I know that everyone that is like multiple of 2. So if something is multiple of 2 and it comes less than in that range, will not be prime, so that I'll mark as false. And then I can just simply go and check that if something is true, then I'll increase the count or just get the index, whatever the question demands. So that also I think is easy as far as I remember. GCD and LCM. Bhai, I got scared of this. I don't know why. Because till I learned the long method, I was good. But just the day I got to learn this short method, that's something like na, A is equal to or B is equal to something like A divide B, something sort of, then I got finished. So we'll get this here. Okay. Let's do this. GCD and LCM. GCD and LCM. GCD, LCM. That's CPP. Again, our hash include IO stream using namespace std. Vajiva, what I'm writing. Using namespace std int main. This is about GCD LCM, so we obviously find of something, some numbers, some n1. I will say a and b in this case. Int ab will take the input of both a and b as well. Then we'll just give it to you solve. I think I should be a bit more specific. For GCD of a cross b, we will do this, and for LCM of a cross b, we will do this. ठीक है भैया. Now comes the real question. Keyword I will write in these two. Int A, int B is okay. So let's take an example. 4 and 6. GCD means greatest divisor. Now the GCD of these two is what? 4 and 6 is what? The greatest divisor of this is 2, of course. Okay. But I've learned is like 4 is 2 into 2. Okay. 6 is 2 into 3. The common things. Common here is 2 only. So 2 is my GCD. Now generally what happens is I remember a little. Acha, got it. We usually choose a bigger one and we write in this way that the smaller one should be our A, bigger one should be our B, and after that I think we do that till this is not equal to 0. Okay, so we find the remainder, which is A modulo B. Okay, then A has to be greater than 0. Yep. So we get the remainder. Now we will say that now A is B and B is equal to the smaller part remainder, and after that we just need to return A. Now I think I got like the basic idea of this is that our GCD of something AB, if I say, then this is always like GCD of first we did B, that is we did here that A should be equal to B, and B is remainder is what? A mod of B. And we'll keep on repeating till our B is 0. and it has also some time complexity, I guess, O of log of, and whichever is smaller, A or B. Now comes the second part. LCM and GCD have like they have a relation. So if we find GCD, then LCM is GCD. There was also this very popular TCS-NQT aptitude question related to this. We generally say that HCF into LCM is equal to A into B. We will use the same for this int LCM and int of A, int of B, and here we'll say that I got the GCD. I need to find LCM. So what I'll say that int result is A multiplied by B, and we need to return this result divided by GCD. So this result, which has to be divided by GCD of A and B. Yep. So A into B divided by the GCD of A and B. Let's run this. Code is already, why I used to run there. This is our GCD LCM. That's CPP. Next time I'll write short names, not this weirdos. GCD LCM. ठीक है भाई, नॉट फाउंड. अब क्या दिक्कत है, सेव करा कि नहीं करा? Let's check again. GCD LCM dot CPP GCD LCM GCD LCM. एक्सपायरी तो नहीं आया. 2 3 16. अच्छा, no, it's not even possible. Add an line. ठीक है भाई, बानो में बह गई थी मैं. Now if I do 2 and 3, so 1 is the GCD and this is LCM. Good to go now. We just need to remember this. I just need to remember this, that I'll get B here and here is A mod of B. So I'll find A mod of B, will set B, and then my B is whatever the remainder. AB is BA, but with a little twist. Okay, so GCD and LCM, the part we used to get most of it is done, which is GCD of A comma B is equal to GCD of B comma A divide B. Okay, next is a factorial. Factorial, I don't think anything is there in factorial. If something is 5 factorial, I'll keep on dividing it and multiplying with the number. No, if 5 is there, so I'll take 5, multiply it by the n minus 1, which is 4, and just keep on following it. And do I need to run a while loop? While n, that is while 5, result is what? Result is result into, for initially we'll take a result of 1, then result into n, then we'll decrease n, which is n minus minus, will make it 4. So that is easy, but don't do this. Power function. What is power function? We'll do this power function later. Count digits we could do. We already did this somewhere here. Armstrong number. We already did this. Sum of digits, just when we are counting or doing the remainder part, we'll add them. Okay. Now we need to do 1, 2, 3, three things. Power function, decimal to binary or binary to decimal, non-trailing zeros, and factorial. So first let me see what is power function problem statement. What is problem statement for power function? A common power function statement in coding interface and DSA platform is given two integers, calculate x to the power n as a result of action, and something to the power 20 to the power 10 is this 2 to the power 5, 2 to the power minus 2 is also possible. This is interesting then. This is interesting, and this indicates that we need to do this in next video because this might get a bit long for someone like me. Okay.